Okay, let's continue our discussion of torque. This time, let's determine the numerical definition of torque. Okay. Ayan. So, say for example, we have a screw here and then we are looking at it face to face, no? So, in reality, the head of the screw, saan ba dito? So, if this were the screw, we are looking at this view here. So, it's just like, parang ganyan siya. The head of my stylus, you consider it as the head of the screw, and then we are viewing it here face to face. Okay? Ayan. Why am I explaining this? Because uh, I hope you realize this. It's really difficult to sketch three-dimensional realities in a two-dimensional surface. That's why I've been telling you since the beginning of this semester to use your imagination, no, in putting depth in our drawing. Okay. So this is the head of the screw now. And then we want to rotate the screw. So let's say we use a wrench. Let me draw a wrench. Let me just erase these things here. So as of now, we know qualitatively that torque is a measurement of the rotating ability of a force, no? So we want to determine it now numerically. So we put the wrench, we let the wrench bite the screw. Okay, pardon my drawing. I love to draw, but seems like it doesn't love me that much. So, ayan. You have lumalabas na ba ang figure ng screw, wrench. This is the wrench. Okay. Excuse me. Ayan. I was about to click the pause. Naabutan yung sneeze ko. But anyway, excuse me. Okay. I don't want to repeat my video again from the start. So, bahala na kayo dyan. So, you just imagine na nasa classroom tayo and then anything goes for a live show. Okay. So, this is now the wrench. Ayan. It looks like a wrench to me now. I hope it is to you. Okay. So, let's say, for example, we want to rotate the screw here counterclockwise. So, itong surface ng monitor ng laptop or cellphone or computer nyo ngayon, we'll take it as the XY axis. So, let me sketch the axis first. Axis. I think I've mentioned this before, no? So, plural, axis, singular, axis. Okay. Charot. So, let's sketch the other axis. So, the usual, let's consider the horizontal as our x-axis. The vertical is our y. So that the rotation of our screw here will happen in the xy plane. So rotation on xy plane. So the axis of rotation therefore is in the third axis, which is the z-axis. So I will sketch it here like this. This is Z, and then I'd say that this is the axis of rotation. I believe I have discussed the meaning of axis of rotation in the first video sa lecture video series under angular kinematics. So please review that. Yan. So you have the axis of rotation here. Now, so say for example, we apply a force here. You know? Let's say yung mechanic or ikaw mismo, you pull the wrench upward, 90 degrees, kunyari ganyan. So this is now the applied force. Okay? And we will determine now the rotating ability of this force. We will examine the factors that will affect how able your force is in causing rotation sa wrench. Excuse me. Okay, now, so we will have to, this is the point of application, no? Ayan. So from the axis of rotation, going to the point of application of the force, we will draw a position vector. So the position vector here is a vector that points the location of the point where the force is applied. So it goes from the origin going to the point of application. This is a vector quantity. So ito yung arrowhead niya for the direction. It started from the axis of rotation now. And we now call this position vector the same label we give it when we were studying kinematics. So this is position vector R. Ayan. So the moment of force F is defined as, ito na yung numerical definition. The torque or the moment of force F is the cross product of position vector R to the applied force. Ching-chigadeng. So the X here is a symbol for, if you recall, cross product, which was the first lesson, one of the first lessons under vectors in the beginning of time of physics for engineers. So it's cross product. What's the other term for this cross product, if you can recall? Correct. It's also known as vector product, as if I can hear you. Ayan. So why is it called vector product? Correct again, because the cross product of these two vectors will result to another vector. So it's like the parents, position vector and force vector, ang offspring nila torque vector pa rin. Yan, si Vector Wood. Hala, ang corny ko. Okay, you don't know Vector Wood. Asan ako? Okay. So, that's why it's called vector product. Why it's called cross product? Obviously, because the symbol here is a cross. Ayan. So, I want you to pause for a while and then let's recall what we learned, hopefully, about vector product in chapter 1, no? In the first discussion. So, we have two generic vectors. Let's say vector A. And then we have to draw the two vectors tail to tail. Let's say if this is vector B. And then we define the angle between the tails of these two vectors as angle phi. The vector product is the product of perpendicular components. So that's the simplest definition. Product of perpendicular components of the two vectors na kino-cross product mo. Of two vectors. Ayan. That is why, immediately, if you know that if vector A is parallel to vector B, then there's no way for them to have perpendicular components. Kung wala silang perpendicular components, alam mo kaagad that ang cross product nila, you immediately know that their cross product is 0. Why? How can you have component na perpendicular kung parallel nga sila? Tama ba? Very good. Another thing, if it's very obvious that the A is making a 90-degree angle with vector B, yan, then the angle between them must be 90 degrees. Remember in your trigonometry, sine 90 will give you maximum value of +1. So if it's clear in the system or in the situation that A makes a 90-degree angle with B, you immediately know that their cross product is maximum for their values. So A cross B here will give you a maximum value, wherein the value is just magnitude of A, magnitude of B, and then you may not write the sine 90 anymore because sine 90 is +1. So it's just A times B. So parang ganon. Okay, klaro ba? Yan. Further recalling, we also have in terms of unit vectors. Yan. In terms of unit vector, kasi cross product man na siya. So meaning to say, our position here can have 3 components. Xi hat. Ayan na naman yung best friend natin, no? Yj hat plus zk hat. The same thing is true for the applied force. The applied force can have 1 component, it can have 2, or it can have 3. So kung kumpletuhin natin, Fxi hat, Fyj hat, plus Fzk hat. And then, i-cross product mo siya. So, meron tayong technique, di ba, na para mas madali. Remember? Meron kang I, and then you go clockwise, J hat, and then you go, ay, hala, saan naman eh? Sorry. J, and then you have K hat, and then there. So, if you go with the direction, I cross J will become K. K cross I will become J. Can you recall that? Let's recall. Okay? So, remember, I cross I, this would be 0 kasi parallel yung unit vectors na yan. They're both going towards positive x. So, pag pareho, di ba? J cross J, 0. K cross K, 0. Or, negative I cross positive I. Basta kay pareho sila ng same axis, 0 yan lahat. Pero pag you go the same direction, you have I hat cross J hat. So, I cross J, that will give you K hat. Yan. And then, J cross K will give you I hat. If you go the other way around, magdi-negative ka. So, if J cross I, it will become negative K. Yan. If you have negative I hat cross K, don't mind the negative here first. You go to your drawing here. I cross K is counterclockwise, so it should give us negative J. Negative J times the negative here, it will give you positive J. So please recall that. Okay? Ayan. So these are things now. So you can always do this if the position and the force vectors are given in I hat, J hat, K hat. Tama ba? So this is the most fundamental definition of torque. Pag naka-unit vector si R at saka si F, and then you do the evaluation here, the I hat, J hat, K hat will give you the direction of the torque, whether it's I, J, or K. Okay? And then the idea is, if you remember, for cross product, the direction of the vector product will always be along the third axis where R and F do not lie. So in other words, if R and F are happening or existing in XY plane, then the torque, the direction of the torque will either be towards positive Z or towards negative Z. That's the definition of cross product. So ito na yung si torque na ngayon ang pinaka-concrete example ng cross product that we have learned in prelims. Okay? Ayan. So let's continue. So, ayan. What I'm trying to say is, if R and F are given this way, and then you do the evaluation, your final answer will give you the magnitude and direction. Okay? However, there are times when the position and the F vector are not given in components. So in that case, we can also have another way of calculating the torque or the moment of a force. So let's go to that next definition. Yan. Okay? So, if hindi ka nag-unit vector, so if we begin with the definition that torque is R cross F, tama pala class. Remember that cross product is non-commutative. Non-commutative. So, do not ever write torque this way, where inuna mong sinulat si F tapos you cross it with R. It's wrong. Okay? It will give you a wrong direction. Kasi nga, non-commutative si torque. So, dapat mauna si R bago ka mag-cross kay F. Okay? So, based on the definition of cross product, the magnitude of the torque, so that's the absolute value, that's the magnitude of torque, is just given by the magnitude of the position vector, the magnitude of the F vector. So if you notice, I did not put the arrow sign anymore because I'm just writing the magnitudes, no? And then you have sine theta. Yan. This will give you the magnitude. So, hindi pa kompleto yan kasi wala pang direction. Magnitude of torque. Wherein, the MKS unit is, you have Newton for force, meter for direction, but this is not equal to joule. No? Unlike sa energy na force times distance, ginawa nating joule. The Newton meter in rotational motion is not identical with energy. Nagkataon lang na pareho sila ng unit, okay? But it's not joule, it's not an energy, but it's the measurement of the rotating ability of a force. Yan. So, if this is the magnitude now, how do we get the direction? So, the direction, ang partner ng RF sine theta for the direction will be the right-hand rule. Right-hand rule, or the RHR. We have discussed this also hopefully we've learned this also sa discussion ng vectors no in the early part of the semester. So for the right hand rule, you curl your fingers of the right hand from vector R going to the direction of vector F, and then your thumb points the direction of the torque. Direction of torque. Okay? Medyo tricky ito. So, what I suggest sa inyo is this. You first sketch the two vectors tail to tail. So, let's go back to my example here. Okay, so F is going upward and your R is somewhere in the first quadrant. So if we connect them now tail to determine the direction, I'd say I'll have my force here. It doesn't have to be unahin si R or si F. Kahit ano lang iuna pag-draw. You have your force there and then the R is somewhere in the first quadrant, tail to tail. So that's R. So that this is the angle between them, angle phi. So your finger now, malihirapan ako kasi mirror image ang aking camera. Anyway, so if I'll go to the first quadrant, ang kamay ko ngayon is in the direction of R, and then I'll go towards F. So the my thumb is going towards me. So it means that the torque is towards positive Z. So ito yung axis natin ha. This is our Y. This is X. Since rotation here happens in the XY plane, so we know that kung kukunin natin ang cross product ni R at saka ni F, ang direction nito nasa Z axis talaga. Pero pipili lang tayo kung papunta bang positive Z or papuntang negative Z. So in this case, pag palayo sa screen or papunta sa observer, papunta sa iyo, that's positive Z direction. But if it's going into away from you, that's negative Z. So again, follow me. R is in your first quadrant and then you sweep it going towards F. F is going in the vertical axis. Okay? I'd rather use okay. I'll use na lang my other hand para parang right sa inyo. So, sa monitor nyo ngayon, ang R ko ngayon is nasa sa first quadrant nyo. I'll curl it upward. So, the thumb is going towards me. So, going towards me or away from the plane, so that's positive Z. So, we say here, so we say therefore that the direction of the torque here is towards positive Z axis, or I can also say it's towards positive K hat, or I can also say towards the observer, which is ako, or pwede ko rin sabihin away from plane, away from the plane. All of these four directions are the same. Okay? So, that's for the direction. I'll just say it like this. Or, meron pang isa. Symbol is circle with a dot here. The dot is like the tip of an arrow that is going towards you. So, yan yung symbol natin. So, if that's the direction, then the magnitude is FR sin theta. If F is, let's just say for the sake of simple calculation, if F is 10 newtons, and then the position here sa wrench is, let's just say, 0.30 meter, 30 centimeters from the screw. And if I'd say that the angle here is, let's say, 60 degrees, angle between R and F. So F and R here are not given in unit vectors. They're given in magnitude and direction. So this is N going 90 degrees. And then R here is at 60 degrees with the horizontal. So the torque of the F now, magnitude is FR sin theta. So F is 10. R should be in meter always. And then the angle between F and R is 60. So 60. And then you have your value here. Pakisolve na lang. That's in Newton meter. This is just the magnitude pa. So that's incomplete answer. But from right-hand rule, direction is towards positive Z. So therefore, in my final answer, I'll drop the absolute value sign and then torque with vector sign. I'll give the magnitude here. Pila man is? 0.3 times sine theta. Wait. Sana? 3 times sine 60 pala. So, it's 2.6. Tama ba? So, you have 2.6. Two significant figures. So, 2.6 Newton meter. And then I can just say here, direction is like that. Or pwedeng 2.6 Newton meter positive K hat. Pwedeng ganyan. So, that's your answer now. So, you don't need to use the I cross I, J cross K. Why? Because your F is given in magnitude direction form. So, pag magnitude direction form, doon ka sa FR sin theta. FR sin theta for the magnitude. And then right-hand rule for the direction. Sila naman ngayon ang mag-partner. Pag nakalimutan mong mag-right-hand rule, kulang yung answer mo kasi hindi mo mabibigay yung direction. Okay? So in this case, klaro dito na ang torque will always be cutting through the plane where the rotation is happening. So since the rotation here is happening in the XY plane, si torque ngayon, ika-cut through niya yan. So either, in this case, it's away from the plane. Ayan. So magdepende siya ngayon. Kung ano, basta kay never si torque magdireksyon ng I hat, J hat, kung ang rotation nasa XY. So, dalawa lang talaga ang choice mo. Either nasa positive Z or negative Z. Kung ang rotation nasa XY plane. If the rotation happens in the XZ plane, kunyari dito naman siya na plane, this is X and this is Z. So, ang torque ngayon is either positive Y or negative Y. Parang ganon. That is why if you have something, a water bottle for example, di ba si water bottle, for example, kung ito water bottle, when you rotate the cap, the threaded cap, counterclockwise, you are able to open the cover, no? Wait, let me get my water bottle. Ayan. So, water bottle. Okay. So, say for example, this water bottle. Okay. I will apply a force now that is tangent to the circle here. It's like the force of the wrench. No? So, if I rotate it counterclockwise, right-hand rule is saying that the torque's direction is upward. So, upward. Yan. And then, I'm able to open the bottle. Kasi because of the threading here, it will rotate. If you want to close it, then the rotation should be clockwise. So, pag nagka-clockwise ka ngayon, although hindi ka naman mag-open ng ganyan ng bottle, no? I'm just showing here the right-hand rule. So ito ngayon, rotation that is clockwise. Pag i-clockwise mo siya, ang torque mo ngayon, ang kamay mo ngayon, the thumb is going downward. So, the downward torque will cause this cover ng water bottle ko to go down. Okay? So, it's something like that. So, that's the idea of the right hand rule. Okay? Mahaba na ba ang video na ito? Kasi I will cut this now in a while. So, what I'm trying to say here is, kung saan ang rotation nangyari na plane, ang torque mo nasa pangatlong axis. So, yun yung diniscuss ko sa inyo ngayon. If you have your water bottle like this, and this is now the axis of rotation because the rotation of the bottle happens in this one. So, if we still take this as the x-axis, and then this now is the z. Yan. The y na lang ito. Yan. So, ito yung force natin dito ngayon, either pag ganon or pag ganyan. So, the torque, so if force is in that direction, this is for opening, no? Parang pag ganon. And then, if force is in this direction, pabaliktad siya. So, the torque can just either be going upward or downward. Oops. Ayan, downward torque. Kasi si F at saka si X nasa axis, nasa plane na ito. F and R, I mean, the radius of this. Ayan, so this is now the position. Kasi dito kasi natin i-apply yung force natin. Either pag ganyan doon, tangential to the circle, or pag ganyan dito. So parang ganyan siya. So we take this as the z-axis. Okay? Ayan. Now, I will have to stop here, and in the next video, I'll show another perspective in solving the torque. So this is just, yung number 1 natin is the cross product. That's number 1. Yung number 2 natin is using magnitude FR sine theta and then direction right hand rule. In the next video, we will look at the same problem but in different perspective, so that you'll really see that there's so many ways in solving torque. You just need to choose your own perspective. Okay, I'll stop here for a while. Please stay well. See you next time.